The Barents Sea. Coordinates classified. The season is not. November in the high Arctic means no daylight on the surface. The ice pack grinds south across the Barents, its pressure waves traveling down through 300 meters of dark water to the seafloor below. The temperature at depth registers barely above freezing. The pressure is 54 times what a human body can survive unaided. At 1,800 feet beneath that surface, something is moving. Slowly, deliberately, in absolute silence. USS Jimmy Carter is not here to fight. She carries 12 torpedo tubes and a weapons load that could end a conventional surface engagement in minutes. Tonight, every one of those weapons is irrelevant. Carter is here for something smaller, something buried, something that cannot shoot back. She is here for the cables. 3 fiber-optic lines lie beneath the sediment of the Barents Sea floor, running northeast from the Olenya Guba submarine base on the Kola Peninsula toward Moscow's strategic command network. 3 redundant arteries carrying the heartbeat of Russia's northern fleet. The command traffic for Yasen-M class attack submarines. The operational orders for the most secretive deep-water program Russia has ever built. The nervous system of Russia's Arctic nuclear deterrence. In the next 4 hours, that nervous system will go dark, and Russia will not understand why for 11 days. What you are about to hear has never been officially confirmed by any government. The operation exists in the negative spaces of the public record. Deployment gaps, congressional briefing fragments so heavily redacted that only the shape of the story survives. Satellite imagery anomalies that only resolve into sense when cross-referenced with Northern Fleet maintenance logs, filed 6 weeks after the fact. Operation Frozen Harvest. 14 days in the most heavily monitored stretch of ocean in the Northern Hemisphere. A covert mission that retrieved 2.3 terabytes of Russia's most sensitive submarine telemetry, severed 3 redundant fiber-optic communications lines connecting Russia's most secret deep-sea program to its strategic command, and withdrew without leaving a trace that Russian forces could definitively attribute in real time. This is the story of how that happened and what it changed. To understand what USS Jimmy Carter did in the Barents Sea, you first have to understand what she is. And to understand what she is, you have to understand the world she was designed for. The Seawolf program came out of an uncomfortable intelligence assessment. In the late 1970s, a United States Navy communications specialist named John Walker began selling cryptographic secrets to the KGB. Walker and his associates operated for nearly a decade before detection. What they sold, the keys to American military communications encryption systems, gave Soviet naval intelligence an unprecedented window into American submarine tracking methods. The Soviets used what they learned to accelerate a generational shift in their own submarine design philosophy. The Akula class, which began entering Northern Fleet service in 1986, came from that acceleration. American submariners who encountered the Akula in the late 1980s reported something their training had not prepared them for: a Soviet submarine that was genuinely difficult to hear. In some frequency ranges, the Akula approached the acoustic performance of the American Los Angeles class. The margin of acoustic superiority that had defined American undersea dominance since the 1960s was narrowing in real time. Congress authorized a response. What the Navy designed was the Seawolf class, 3 submarines, each costing over $3 billion in 1990s money, each the most capable attack submarine ever built by any nation. The specifications were extraordinary. 52 weapons per hull, more than double any predecessor. Sustained submerged speed exceeding 35 knots. A reactor plant newly engineered for reduced acoustic output. Advanced shock isolation mounting for every internal system. A sonar suite that redefined what passive underwater detection could achieve. And sound quieting technology so advanced that during Seawolf's initial sea trials, experienced sonar operators described attempting to track her as listening to an ocean with no submarine in it. 3 hulls were completed before Congress, with the Cold War ending and the strategic rationale for Cold War submarine designs dissolving, canceled the program. USS Seawolf, USS Connecticut, and the 3rd hull, the last, the longest, and the strangest of the 3, USS Jimmy Carter. Carter is different from her sisters in a way that becomes obvious the moment you look at her specifications. Her hull is 100 feet longer than Seawolf or Connecticut. That additional section, inserted during construction at the Northrop Grumman facility in Newport News, Virginia, contains what the Navy formally designates the multi-mission platform. The MMP is described in public documents with deliberate vagueness. A payload section accommodating specialized equipment. What that means in practice: a lockout chamber system, a pressure-equalized trunk that allows special operations personnel or remotely operated vehicles to exit the submarine while submerged at operational depth. Reconfigurable internal space for classified mission packages, secure data collection and storage systems, passive sensor arrays whose specifications remain classified, and a capability that no other submarine in the American fleet possesses in Carter's form: the ability to physically interact with undersea infrastructure at depth, in darkness, without surfacing or revealing her presence. Carter's deployment history is documented almost entirely by its absences. Port visits recorded, exercises attended, and between them, gaps, weeks and months where her official record shows nothing. Where Carter was during those gaps, what she was doing, and what she brought back afterward are among the most tightly held secrets in the American intelligence community. The gap that aligns with the events of Operation Frozen Harvest is one of the longest in her public record. To understand why Carter was in the Barents Sea, you need to understand the organization whose infrastructure she was targeting: GUGI, the Glavnoye Upravlenie Glubokovodnike Isledovani, the main directorate of deep-sea research. Most people have never heard of GUGI. That is not an accident. GUGI is not the GRU. It is not the FSB. It is something older and, in some respects, stranger, a scientific and military hybrid whose public mission is oceanographic research and whose actual mission encompasses some of the most sensitive covert maritime operations Russia conducts. GUGI reports directly to the Russian Ministry of Defense, operates under a level of classification that places it above most other Russian intelligence organizations, and maintains a fleet of assets with no direct equivalent in any Western Navy. On the surface, GUGI operates a collection of specialized research and cable-laying vessels. Beneath those surface ships, operating at the extreme depths of the ocean floor where no conventional submarine can function, GUGI maintains a fleet of nuclear-powered deep-water submersibles: the AS-12 Losharik, the AS-31, the Podmoskovy Mother Submarine, a converted ballistic missile boat redesigned specifically to carry and deploy these deep-water vehicles. Together, these assets give Russia the ability to place, service, and recover equipment on the ocean floor at depths that most naval submarines never approach. What that equipment does is classified. But from satellite imagery, signals intercepts, and the behavioral patterns of GUGI vessels documented over 20 years of open-source analysis, defense researchers have built a coherent picture of the organization's primary activities. GUGI maintains Russia's underwater hydrophone networks. It operates the deep-water communications infrastructure connecting Russia's Northern Fleet submarine bases to Strategic Command. And it conducts intelligence and interference operations against undersea cable systems belonging to Western nations. GUGI has, in documented cases, placed recording equipment on commercial fiber-optic cables crossing the Atlantic and Pacific. The capability is acknowledged in Western intelligence assessments. It is not publicly disputed. GUGI does to Western cables what Carter was about to do to Russia's. The cables running out of Olenya Guba were GUGI's own communications lifeline. 3 redundant fiber-optic lines buried in the Barents Sea floor, connecting the Olenya Guba submarine base, home to several Yasen-M class attack submarines, and supporting facilities for Northern Fleet deep-water operations, to the command network in Moscow. The redundancy was deliberate. 1 cable fails, 2 remain. 2 fail, 1 maintains communications. 3 simultaneous failures were not considered possible by the engineers who designed the system. The assumptions embedded in that design had a name: the bastionization strategy. Russia's concept of the Arctic bastion dates to the Soviet era. The Kola Peninsula and the waters of the Barents and Kara Seas surrounding it are, in Russian strategic doctrine, a protected zone defended by overlapping layers of submarine patrols, surface forces, airborne maritime patrol, and an extensive network of fixed and mobile acoustic monitoring systems blanketing every approach corridor. Within the bastion, Russia's nuclear-armed ballistic missile submarines can conduct their patrols with confidence that they are not being tracked. The bastion is the sanctuary from which Russia's nuclear deterrence operates. The acoustic monitoring architecture protecting that sanctuary is known in Western assessments as the SKAT system, a network of fixed hydrophone arrays on the seafloor, supplemented by mobile monitoring buoys deployed at varying depths across the approach corridors. The coverage is overlapping and dense. Every major approach to the Kola Peninsula from the Norwegian Sea and the open Barents is monitored by multiple layers of sensors. Planning to penetrate that coverage is not a matter of simply going slower and quieter. It requires building a detailed model of the entire monitoring architecture, where the fixed arrays are, what their coverage geometry looks like, which corridors are most densely covered and which have natural shadows, and whether any temporal gaps in coverage exist that can be exploited. The intelligence preparation for Operation Frozen Harvest took approximately 18 months. It drew on decades of accumulated American intelligence collection about Russian Arctic monitoring infrastructure, signals intercepts from SKAT station transmissions, satellite imagery of installation and maintenance vessels, acoustic data from American submarines that had operated at the edges of the bastions over many years, and in some cases data from previous Carter deployments that has never been described in any public document. What the analysis found, buried in the pattern data, only visible when multiple independent intelligence streams were cross-referenced, was an anomaly in the Barents monitoring coverage. Every 18 to 24 days, when specific meteorological conditions combined with specific ice pack configurations in the central Barents, a drift pattern emerged that pushed a set of the mobile monitoring buoys off their designated stations. The buoys were not fixed to the seafloor permanently. They were moored at depth on cables long enough to allow limited movement. When Arctic surface currents drove the ice pack in a specific direction, those currents carried the buoys to the limits of their mooring cables. Their acoustic coverage zones shifted with them. For approximately 4 hours, a specific approach corridor running northeast from the Norwegian Sea into the central Barents lost its buoy coverage. The fixed SKAT arrays still functioned, but between fixed arrays, where buoys normally filled the acoustic gaps, the coverage thinned to the point where a submarine running at maximum acoustic quiet could transit without reliable detection. The corridor was narrow. The timing window was tight. The conditions for the drift were predictable only within a range of several days, enough to require Carter to position herself in the Norwegian Sea and wait for the exact conditions to align. Mission planners calculated that in the November period they were targeting, the drift conditions had a 78% probability of occurring within a 6-day window. Carter needed to be on station before that window opened. The mission timeline built around it: 8 hours to transit the corridor at acoustic quiet speed, 72 to 96 hours on station for the intelligence operation, 8 hours to transit out. Total mission duration, including Norwegian Sea staging, 14 days. 14 days in which Carter would need to remain undetected, not just during the corridor transits, but in the target area itself. 87 miles off Murmansk, within theoretical range of Northern Fleet helicopter patrols, within the coverage zone of the Olenya Guba-based submarine forces, and directly beneath the approach path of Russian maritime patrol aircraft flying from Kola Peninsula air bases. The risk was accepted. The orders were cut. Carter sailed. I spent time going through the open-source satellite imagery from Carter's departure period and comparing it to publicly documented Northern Fleet exercise schedules. One data point kept coming back. The gap in Carter's documented port presence doesn't match any standard transit pattern to or from Pacific Fleet operations. The math only resolves if she spent 14 days somewhere her deployment record does not show. That somewhere is the only place where a 14-day gap and a Northern Fleet communications outage can be explained by the same event. The Barents Sea, 87 miles from Murmansk. Carter had been underway for 48 hours when the first serious complication materialized. The passive sonar systems of her mission package, sensors built into her hull, and the towed array she streamed behind her at reduced speed, detected an anomalous contact in the southern Barents. Not a submarine, a surface ship, stationary. Its acoustic signature and the electromagnetic emissions from its superstructure identified it as an AGS-class vessel, an acoustic intelligence ship, Russia's equivalent of the American Tagos monitoring platforms. A surface ship equipped with a towed sonar array, positioned where it could listen to the approach corridors with exactly the kind of extended passive monitoring that Carter was trying to avoid. The AGS was not positioned directly on Carter's planned route, but its listening cone extended into the approach corridor's most critical section, and the risk margin it created exceeded what the mission parameters had allowed for. Carter's commanding officer revised the approach. The new route added 14 hours to the transit. It required Carter to pass within 40 miles of a known fixed SKAT array, close enough that the crew went to maximum acoustic quiet protocols for 6 hours. No cooking. No unnecessary movement through the boat. Machinery on shock isolation mounts. The kind of sustained operational discipline that every member of the crew had trained for, but that at depth in the Barents 87 miles off Murmansk carries a different weight than it does in the training exercises. The AGS vessel departed the area 72 hours later. Russian patrol logs, accessed through intelligence channels in the months following the mission, show no detection contacts during that period. The modified route had worked. Carter resumed her original approach geometry and arrived at the corridor entry point on schedule. The ice pack drift forecast showed a 91% probability of window alignment within 36 hours. The window opened as predicted. What 140 people do in the minutes before a transit like this one has no official name in any submarine operations manual. The procedures are clear. Maximum acoustic quiet, minimum machinery load, watch rotations tightened, all non-essential personnel kept from passageways where footsteps could transmit into the hull. What happens beneath those procedures is something the crew does not discuss and does not need to. Every person on the boat understands what the next 8 hours represent. They move to their stations, they run their checks, and they become, collectively, as quiet as the water around them. The commanding officer made one circuit of the control room. No speech, no announcement. The boat simply began its run. Carter transited in silence. 8 hours at acoustic quiet speed, threading the gap between fixed arrays while the buoys sat displaced from their stations by the Arctic current. The window had closed behind her by the time she reached the target area. She was inside the bastions, and she was going down. The descent to 1,800 feet required careful ballast management. Diving a submarine generates its own acoustic signature. Changes in internal pressure, pumping systems, trim adjustments. The descent profile at this location needed to minimize that signature without sacrificing time. Carter settled to operational depth and held station above the target coordinates. Below her, the Barents Sea floor. Below the sea floor, 3 cables. Finding them required the bottom mapping arrays of the multi-mission platform's sensor suite. Fiber-optic cables don't radiate. They carry light through glass. No acoustic signature, no electromagnetic emission. Finding a buried cable at 1,800 feet means knowing approximately where it is and imaging the seafloor carefully enough to see the slight sediment ridge above an armor-sheathed cable, the anomalous bottom reflectivity where the cable's steel braiding differs from the surrounding geology. It took 18 hours of systematic bottom mapping. The MMP operators building their picture of the seafloor in slices, the crew cycling through watch rotations, eating cold food, maintaining the silence protocols. The work of intelligence collection is not always dramatic. Sometimes it is just sustained patience at depth in the dark. The primary cable resolved in the sonar data first. Its armor signature was clear. Steel-braided outer jacket over the fiber core, running northeast to southwest. The secondary appeared 220 meters to the east. The tertiary, lighter, possibly a newer installation, 190 meters west of the primary. 3 cables, all found, all mapped, all confirmed against the mission planning data. Carter's commanding officer gave the order. The first phase of Operation Frozen Harvest would begin. The ROV exited the lockout chamber and descended toward the seafloor. At 1,800 feet, in total darkness, active lighting would have been an unacceptable risk. The vehicle moved on acoustic positioning guidance. Its own sensors tracked the seafloor rising below as the remaining 200 feet closed. The primary cable appeared in the vehicle's sonar at exactly the position Carter's bottom mapping had indicated. The ROV located it in 8 minutes. The fiber-optic cable tapping technology deployed from the ROV is classified. What is publicly acknowledged in defense research literature and in the historical record of programs like Ivy Bells, the Cold War operation that placed recording devices on Soviet military cables in the Sea of Okhotsk during the 1970s, is that the general capability has existed in some form for decades. The working principle involves bending an optical fiber at a controlled angle, causing a fraction of the transmitted light to escape the glass core, where it can be captured and read without interrupting the signal. The operational challenge is executing this without creating measurable signal degradation at the receiving end. Any drop in signal strength at Olenya Guba could trigger a technical inspection that would reveal the tap. Whether Carter's system achieved that precision is not documented in any public source. What is documented in the congressional briefing fragments available is that the tap operated for 72 hours. For 72 hours, everything passing through Russia's primary deep-water communications cable between Olenya Guba and Moscow's command network flowed through Carter's data collection systems. On Carter's mission deck, in the section of the multi-mission platform configured for signals exploitation, 3 intelligence specialists who had been embarked specifically for this operation worked in overlapping 6-hour shifts. They were not reading the data in real time. The volume was too large, the encryption layers too dense for meaningful tactical processing at depth. What they were doing was verifying integrity, confirming that the tap interface was capturing cleanly, that no signal degradation was registering at the splice point, that the storage arrays were receiving complete and uncorrupted data streams. The logs they kept during those 72 hours are classified at a level above most of the operation itself. What they knew, working in a sealed compartment 1,800 feet beneath the Barents Sea, was that the collection was running without interruption, and that what was accumulating in the storage systems was something no American intelligence platform had ever obtained in this form. And what was flowing through it was extraordinary. The 2.3 terabytes collected during those 72 hours included command traffic, operational schedules, and personnel communications. But embedded in the cable stream were something that intelligence analysts had been trying to obtain through passive means for years: telemetry feeds from Yasen-M class attack submarines conducting training operations in the Barents Sea. Not routine administrative traffic, real-time operational data, reactor performance parameters, propulsion system signatures under different speed and depth conditions. Acoustic emission profiles from the submarine's machinery under operational loads. Maneuvering performance data. The complete acoustic and operational characterization of Russia's most advanced attack submarine class, captured under controlled testing conditions by its own operators with no awareness that anyone was listening. The Yasen-M, designated grainy by NATO, entered Russian service in 2014 and represents the most significant advance in Russian submarine quieting technology in a generation. Its pressure hull is coated with acoustic damping anechoic tiles. Its propulsion systems are mechanically isolated from the hull. Its reactor plant is designed for minimal acoustic output. The submarine is, by all available assessments, the quietest large nuclear boat Russia has ever put in the water. Characterizing its acoustic signature through passive tracking in open ocean conditions is painstaking. A submarine this quiet, in the noise environment of the Norwegian or North Atlantic Sea, yields its signature slowly, data point by data point, encounter by encounter, building a recognition profile over months or years of patient collection. The cable intercept compressed that timeline to 72 hours. What's most surprising about this case isn't the intelligence value of the cable tap itself. It's that the Russian engineers who designed the GUGI network had built it to resist disruption. 3 redundant cables, independent routes, hardened for physical survivability. But they had not designed it to resist interception. Disruption and interception are different threats, and the architects of the Olenya Guba network had addressed one while leaving the other completely open. A network can be simultaneously difficult to break and trivially easy to read. GUGI's network was both. 72 hours after the tap went operational, the data verification completed. The collection was intact. The 2.3 terabytes were secured in Carter's storage systems. The mission's first objective was achieved. Then came the question of the second. The ROV was recovered to the lockout chamber. Its cable tapping interface was removed, a different tool attached, and the vehicle descended again. The decision to proceed to physical severance, to move from intelligence collection to deliberate infrastructure sabotage, is the aspect of Operation Frozen Harvest that generates the most analytical debate in the available documentation. The intelligence objective was already achieved. The Yasen-M telemetry was already in American hands. Cutting the cables added nothing to the intelligence take. What it added was a message that could never be delivered in words, from a government that could never officially acknowledge the operation. But a message that Russia would understand completely once its own engineers analyzed the cut cable ends. We were here. We found all 3 cables. We stayed for 72 hours without your monitoring systems detecting us. We could have done this any time we chose to, and you would not have known until the signals stopped. On paper, the severance seems like unnecessary escalation. In the logic of covert deterrence, the language that great powers speak when they cannot speak publicly, it was a precisely calibrated communication. You can interpret it as you like. We'll say plainly that in our assessment, it was the correct decision for exactly that reason. A covert capability demonstration that the adversary receives and cannot dispute, cannot publicly protest, and cannot ignore is the most efficient possible use of the operational window. Russia would have to respond. But they would have to respond without admitting what they were responding to. The ROV made 3 trips to the seafloor, 3 cables, 3 clean cuts. The primary cable went dark at 03:17 local time. The signal ceased. Not a spike, not a degradation curve, just absence. The receiving equipment at the Olenya Guba node registered the loss automatically and flagged it for technical review. The secondary cable went dark at 03:31, the tertiary at 03:52. At Olenya Guba, 3 screens went blank in the same 35-minute window. The on-duty technicians ran the standard protocol, verify the transmitting equipment at their end, confirm the local systems are functioning, then escalate the fault to GUGI maintenance channels. Everything at Olenya Guba checked out. The problem was in the cables. 3 separate cables, 3 independent routes, failing simultaneously. Their training had not prepared them for this. The initial log entry, filed at 0423, described the event as simultaneous cable fault, probable environmental cause, nature undetermined. Northern Fleet Command received the notification as a routine maintenance alert. Meanwhile, 87 miles offshore, Carter was already in motion. The ROV was secured, the lockout chamber sealed. The mission package switched to secure storage mode. Carter turned away from the target area and began the transit that would bring her back through the acoustic corridor and out of the bastions. Consider for a moment what it is to be the commanding officer of a submarine at this point in an operation. You have just severed 3 fiber-optic lines connecting Russia's most secretive deep-sea program to Moscow's command structure. You are carrying 2.3 terabytes of intelligence that didn't exist 96 hours ago. Your exit route passes closer to fixed Russian acoustic monitoring arrays than your entry route did. And you have no way of knowing whether any alarm was triggered by anything you did in the last 4 days. Any anomaly in the cable signal quality, any acoustic emission from the ROV during its operations, any pressure disturbance from the lockout chamber that might have been detectable at range. You run silent and you trust the engineering. Carter cleared the acoustic corridor with 51 minutes to spare before the buoys drifted back to their monitoring stations and coverage closed. She was out. She was clean. She had what she came for. And 87 miles behind her, a Northern Fleet communications officer was about to start doing math on the simultaneous failure of 3 independent cable routes and arriving at a number that didn't fit any environmental explanation. The officer's name is redacted in every available document. What is documented is that his technical assessment, filed approximately 72 hours after the cable failures, used the Russian military term for deliberate action. Sabotage. The assessment reached this conclusion by analyzing the failure signatures remotely, using electrical measurements on the intact sections of the severed cables. Environmental cable damage from ice, seabed pressure, trawl gear, anchor strike produces irregular break patterns. Force applied externally and suddenly fractures the armor unpredictably, with secondary damage signatures in the surrounding material. The signals coming back from the Olenya Guba cables told a different story. The breaks were clean, smooth at the ends, consistent with a precision-cutting tool applied under controlled conditions. The report went through Northern Fleet Command to Moscow. The GRU and FSB were brought in. A security investigation was initiated that involved technical assessment teams, signals intelligence analysts reviewing SKAT logs for any contact that might have been dismissed as background noise, and senior officers whose clearances allowed them to see the full picture of what the Bastion's monitoring architecture had and hadn't recorded during the relevant 14-day period. What those officers found in the acoustic monitoring logs was the most unsettling possible result. Nothing. No contacts, no anomalies, no indication that any foreign submarine had been within 200 miles of the cable severance site during the entire operational period. Carter had been, from the perspective of every sensor Russia had in place, invisible. The absence of evidence was itself the conclusion. If the cables had been cut deliberately and the monitoring systems had detected nothing, then the bastionization strategy had failed in its most fundamental purpose. A foreign submarine had operated inside the bastions for at least 14 days. It had accessed the most protected undersea communications infrastructure on the Kola Peninsula. It had departed without a trace, and Russia could say nothing about it. Here is the uncomfortable position, and we'll state it plainly. Russia's decision to absorb the frozen harvest operation in silence was not weakness. It was strategically necessary in a way that reveals the current state of the undersea competition more clearly than any official statement could. Russia had 2 options after the investigation concluded. Acknowledge publicly what had happened, which would require admitting that the bastionization strategy was penetrable, that an American submarine had operated undetected for 2 weeks inside the Northern Fleet's protected zone, and that the redundant communications network built to resist exactly this kind of operation had been defeated by a single platform in a single 96-hour window. Or say nothing, repair the damage, address the vulnerabilities, and maintain the posture that the bastions remain secure. Russia chose silence, and our assessment is that the choice reveals a specific kind of strategic calculation. Russia understood that the United States had demonstrated a covert capability advantage in undersea operations that Russia currently cannot match in kind. Not firepower, not fleet size, covert undersea operations dominance. The ability to demonstrate capability inside the adversary's most protected waters without creating a crisis that requires a public response. When a nuclear-armed power absorbs a significant covert infrastructure attack and says nothing, it's not because the attack didn't matter. It's because the alternative, escalation without the capability to prevail, matters more. This is a different kind of strategic pressure, and it has implications that extend well beyond the Barents Sea. Here is the question worth sitting with. The same capabilities that allowed Carter to operate inside the bastions and sever Russia's communications network can in theory be turned against the undersea cables that Western economies depend on. The transatlantic fiber connecting Europe and North America. The Pacific cables linking Asia and the Americas. These cables carry more than internet traffic. They carry financial settlement data, military communications routed through commercial networks, the operational coordination of global trade. They are almost entirely undefended. Russia has documented operational experience in placing equipment on commercial cables in the North Atlantic, using GUGI assets. Does knowing that the United States possesses and employs this capability make you more confident in undersea infrastructure security because at least someone is paying attention, or less confident because the technology is clearly operational on both sides? Comment below. The people who think about this for a living genuinely disagree. The GUGI cable repair operation began 6 weeks after the failures. Deep-water cable-laying vessels from the Kola Peninsula, equipped for winter Arctic conditions, transited to the severance sites and conducted in-situ assessments. The cable ends told them what the remote diagnostics had already suggested: clean breaks, tool marks. Missing sections where several centimeters of cable at each cut had been removed by the ROV's manipulator and taken with it, collected presumably as operational confirmation that the cuts had been executed as planned. The cables were repaired, new fiber spliced in, armor restored. The signal came back online, first the tertiary, then the secondary, then the primary. New routing was implemented across different seafloor geography that Carter's bottom survey had not covered. Additional monitoring buoys were deployed at higher density across the corridors Carter had transited. The specific ice pack drift window that had enabled the approach was studied, and a new buoy configuration was designed to maintain acoustic coverage even during the drift conditions. 6 Northern Fleet officers associated with communications security and acoustic monitoring were reassigned. Not court-martialed, not publicly disciplined. Simply moved to different commands, different responsibilities. In Russian military culture, a quiet reassignment after a security incident is understood to be accountability without acknowledgement. The gap was closed, but closing the gap didn't close the damage. The 2.3 terabytes were already at Fort Meade. The Yasen-M acoustic profiles were already being integrated into targeting algorithms and recognition databases, and the intelligence those profiles generated was already beginning to pay operational dividends in ways Russia had no way to trace back to their source. In the 18 months following Frozen Harvest, American and NATO submarines operating in the Norwegian Sea and North Atlantic demonstrated a measurably improved ability to locate and track Yasen-M submarines during transit operations. Classified assessments from the period, referenced in later budget testimony in terms that are carefully sanitized but legible, describe an anomalous improvement in tracking rates that analysts attributed to better acoustic characterization of the Yasen-M class. Submarines that had previously conducted North Atlantic transits without being tracked continuously from departure were, in the period following the operation, tracked almost from the moment they cleared the Kola Peninsula. One detail from the available documentation that stayed with me: the congressional briefing that contains the 2.3 terabytes figure is heavily redacted throughout, but in one section, a phrase survived the redaction: unprecedented characterization of class operational parameters. The brackets tell you what's in them. There is only one submarine class whose characterization would be described in those terms, in that period, in a document discussing Arctic underwater intelligence collection. The Kremlin knew something had changed in American undersea tracking capability. The behavioral evidence was visible in the Northern Fleet's own operations data. Submarines being detected at ranges and in circumstances that hadn't occurred before. What the Kremlin did not know, and what American intelligence worked carefully to protect, was where the new capability had come from. If the Yasen-M profiles had been obtained through passive tracking, there was no way to prevent future collection. If they had been obtained through cable interception, addressing the vulnerability required changes that would be enormously expensive and difficult to execute without disrupting ongoing operations. The compartmentalization around frozen harvest protected the source. The Yasen-M tracking improvement continued. Will Russia successfully build an undersea communications architecture that defeats a future Carter-class operation before the next mission sails? The work is underway. Satellite-linked relay systems, hardened fiber with diversified routing that avoids the seafloor areas previously mapped by American submarines, additional fixed monitoring infrastructure at the approaches to the bastions. Comment yes if you believe the Russian hardening program will succeed in closing the vulnerability. Comment no if you believe Carter and submarines like her will always find the next gap. We'll be tracking this as Russian deep-water infrastructure becomes a more prominent feature of the public defense debate. Your prediction goes on record now. What stands out about Operation Frozen Harvest, looking at it whole, from the intelligence preparation through the 14-day mission through the aftermath, is how completely it inverts the conventional image of military power. No carrier groups, no missiles, no surface fleets, no visible application of force at all. A single submarine, a crew of approximately 140 people, 14 days, and the result was that Russia's most secretive deep-water program lost communication with Strategic Command. Its most advanced attack submarine class was acoustically characterized by the adversary's targeting systems, and the strategy it had built Arctic deterrence on for decades was demonstrated to be penetrable. The competition beneath the waves in the Arctic looks nothing like the naval competition of earlier eras. There are no fleet engagements in the Barents Sea, no surface forces massing at national borders, just submarines, moving in silence, doing things to each other's infrastructure that neither side can officially acknowledge and neither side can officially ignore. USS Jimmy Carter is still active. Her deployment history since the period of Operation Frozen Harvest is, as always, a series of official records interrupted by classified gaps. She was documented at Naval Base Kitsap, Bangor for scheduled maintenance in 2024. What she was doing in the water between documented port periods is the same thing she has always done, operating in the spaces that don't appear on any public map, performing the work that doesn't appear in any public record, and demonstrating capabilities that both sides in this competition understand without either of them saying so aloud. The next drift window in the Barents monitoring coverage will open when the ice pack moves and the buoys shift off station. It will last approximately 4 hours. The question neither government will answer publicly is whether anyone will be there to use it. If you want to understand the undersea competition that shapes global power without making the headlines, subscribe to Deep Blue Warfare. We cover the operations that matter with the specificity they deserve. Hit like if this story changed how you see submarine warfare. Share it with someone who follows intelligence and defense. And drop your prediction in the comments, yes or no on Russia's infrastructure hardening program. We'll see you at depth.